In this question, we are given an array where we want to find out the count of subarrays where the maximum element in the array is appearing at least k times. For example, in this input, this is one subarray, this is another subarray, this one, this one, this one, and this whole array is also this kind of subarray. To solve this problem, we will be using sliding window approach. For example, here we are taking I and j. So j will be moving until we find the maximum element, which is 3, to be appearing at least k times. So it will stop right here because maximum element 3 is appearing at least 2 times. So logically we can say that from I till this point is one subarray, but if we will include other elements appearing after this point also will be this kind of subarray, because if we are including one, the count here is going to be at least 2. So instead of counting it as 1, we will count all the subarrays that can be formed using next elements. So we will count it using n minus j plus 1, which will be giving us 3. Now we will move the I, because we have counted all the subarrays that can be formed starting from the I. So we will move the I ahead. And here also from the I to j, the subarray is valid. And since it is valid, the same formula will be applied to count the subarrays, which also will be 3. Now I will move ahead again. Now we will move the I ahead because starting from 2, we have already counted the subarrays. So we will move the I to 1. The same thing will happen, which will result in 3. Again we will move the I. Same thing will happen again, but here this subarray is not valid anymore. So we will move the j ahead. This is also not valid. Then again we will move the j. This is also not valid. So the total answer here is 12, which is correct answer. And the code will look like this.